Hello everyone and welcome to Probability and Statistics. We've been working with continuous random variables. In an earlier video we derived the joint PDF and also the marginal PDF. So now what we're going to use these is to find a conditional probability distribution of y given that x is equal to 1. So what this is going to be is f of y given x equals to 1. And the equation for this is fxy of x equal to 1 times y of y and f of x with x equal to 1. And of course this formula, oops, move this up here. This formula up here is this formula, and then this formula down here is this formula. So all you have to do really is just sub those straight in with x equal to 1. And then you solve, because for the actual distribution, you don't need any values for y. You want it to remain a variable. And we can kind of define the range of it at a later point. So going into this, we've got 1 over 24 of 1 plus y all over 1 over 6 plus 1/12. And if you go ahead and solve this out, do some simplification, you end up with 1 plus y over 6 is equal to f of y given x equals 1. That's all there is to it. The only hard part is doing the integral for this one and the integral for this one to find these two equations. But then this one falls right out because all you have to do is sub in what the value of x is. And then you have your conditional. Now there is one little thing about this. You want to define a range for this to make sure that it's applicable over the specific area. So if you remember from one of my earlier videos where we actually drew out where this was relevant, the area that it works over, you have something like this, which this is 2, and then you have x equal to 1, and 3 out here, closing this off. So this area, this enclosed area right here, was where we were finding the probabilities of particular things. So now we were finding the probability of y given x equals to 1. Well, x equals to 1 is just this line. So we're finding the probability of a y on this line by doing this equation right here, basically. So we have to define the range, and if you do this, well, this is a y equals x, and this is a y equals x, basically. So this point is going to be 3, and then this point is going to be 1. That wasn't a very good drawing, but it goes to this point over here. So now you know that y, this equation, this conditional for y, is valid for y greater than 1, but less than 3. And that is your final answer for the conditional probability distribution.